Hi there, welcome to this video tutorial. It's Python for Engineers video tutorial in which I'm going to talk about object references. Okay, I think the best thing for me to do is to just show you some examples and explain how Python behaves with object references, because that's really all you actually need to know. So first of all, let me show you why this is something you might need to know about. So let's say I create this a equals 10. Okay, so I create an integer in the computer's memory with value 10. So somewhere in the memory of the computer there's a piece of memory which is encoded to equal the value 10, and I assign the name a to it. Okay, so a is the name I'm giving to this. Okay, so I can then recall it any time. So a equals 10. That's very good. And then let's say that I do this: b equals a. And then I look at what b equals, and sure enough, b equals 10. Now, if I change what b equals, so for example, if I say b equals 20. And have a look at b, sure enough b equals 20, and if I check a, then a is still 10. Okay, so that all kind of makes sense. Hopefully that's intuitive. But now I'm going to do something a little bit different. What if I create a list? I'm going to call this p equals 1, 2, 3. Then I'm going to create, and I'm going to do the same thing. I'm going to say q equals p. So q is a list 1, 2, 3. And then if I modify q, so if I say q.append 4, look at q, 1, 2, 3, 4, that all makes sense so far. But now if we take a look at p again, we'll notice that p has also changed. So p, we defined p equals 1, 2, 3. We defined q equals p. We modified q, which looks great, but that also had the effect of modifying p, which appears on the face of it to be different to what happened above when we did a equals 10, b equals a, we modified b, so now b equals 20, b equals 20, but a still equaled 10. So it appeared that the behavior was slightly inconsistent. In fact, the behavior is not inconsistent if you understand the way that Python handles objects and references. So let me go through this in a little bit more detail. So what I did here, if we go right to the top, if you type this statement a equals 10, what you're doing is you're kind of doing two things. First of all, you're creating an object in the computer's memory, an integer with value 10. Now, by saying a equals 10, you can kind of think of this as a bit like sticking a label on the object. So we create an object in the computer's memory called 10, and this is a bit of an analogy, obviously, but imagine that we just stick a post-it note or some kind of label, hang a label on our object 10, and write a on the label. So basically, we've now given our object this name a by hanging a label on it. Now, here, where we said b equals a, what we essentially did there was say, well, create a new label called b, and also hang that on 10. So we've got one object in memory, an integer called 10, and now it's got two labels hanging off it, or two post-it notes stuck to it, however you want to use the analogy. One with a written on it, one with b written on it. At this point here, we do b equals 20. So what we do is we create a whole new object in memory. There's another object being created in memory, an integer with value 20, and we've hung the label b on it. Now, because we've already created the label b and hung it on 10, what we've effectively done is we've gone over to 10, taken the label b off 10, and gone and hung it on 20. Okay, so now there's two objects in memory, 20 and 10. One's got the label b hanging on it, and one's got the label a hanging on it. And so b still equals 20, and a still equals 10. Okay. Now if we come to the second example with the list, This is very similar. So when we do this operation, we create an object in the computer's memory, which is a list containing 1, 2, and 3. And we hang a label on that object with P written on it. Here, we do Q equals P. We take another label, we write Q on it, and we hang it on the same object. Okay, so far, so much the same as what we did above. However, the difference comes here in this line. Here, we don't create a new object in the computer's memory as we did before, and the key thing is we don't have the equals sign. So this equals sign here, b equals 20, this signifies that we've created a new object in the computer's memory called 20, and we've gone and hung a label b on it, which was previously hanging on a, so we had to go and steal it. Here, this q.append is not a function that creates a new object. This is a function that modifies an existing object. Okay, so it goes and finds the object which has the label q hanging on it, and it modifies it. It appends 4 to the end. But that same object also had the label p hanging on it, if you remember, because we did this. Okay, so here the equal sign, because it's an equal sign between two references, we're not creating an object on the right hand side. This is because what we've got here is p. It's not an object, it's a reference, right? It's a reference to our existing object. Okay, so this instruction is kind of different to this instruction. This instruction means create an object, hang this label on it. This means go and hang this label on the same object that this label is hanging on. Okay, so then when we come to inspect Q and P, it appears like they've both changed, but it's not that they've both changed, it's just that there's one object in Python in the computer's memory, and P and Q are labels which are both hanging on the same object. Okay. Now the same thing applies when you pass to a function. So here I've created a function called pass me a list, and it's got one input argument, and the input argument is to append 0 to the list. Okay, so if we just, hang on, I better just run that. Okay, so if we, for example, pass me a list, we pass it p. Okay, okay, that's run. Then we inspect p. Sure enough, p's now been modified. It's had 0 appended to it in the function, and of course q also looks like it's been modified, even though q never even got passed to this function. So I should show you a different thing. Of course, also what I could do is I could say, instead of a, let's see what this does. Instead of a.append, if I do a equals 9, 10, 11. Okay, let's see what this does. Okay, this is another thing. Right, so it pass me a list, right? Oh, sorry. Okay, and then we'll call this function again. Now pass me a list, and we'll pass it p. Let's just see what happens. Then we'll have a look at p. Okay, so interestingly, p hasn't changed at all, and q hasn't changed at all. And this is because what we did in the function here was not modify an object that existed. By having this equals sign and putting a list on the right hand side, we created a new object, a new list in memory, and we assigned it the label a within the scope of this function. Okay, so of course a in the scope of this function is another label. It's another label which has been hung on the object p, on the object that was pointed to by p when we passed it to the function here. So essentially what we've got now is operating inside this function. We've got at this point, the point we pass it in, we've got our one object, which is our list 1, 2, 3, 4, 0, and it's got 3 labels hanging on it. Okay, it's got P hanging on it, it's got Q hanging on it, and it's got this new label hanging on it, A. And what we do on the first line of the function is we create a completely new object, unrelated to the object that we were referring to, and we take the label A off our object 1, 2, 3, 4, 0, and we hang it on this new object 9, 10, 11. And so by doing that, P and Q are completely unaffected, because what we've done here is we've taken A off and we've hung it on something else. Whereas before, when we said A.append, that operated on the object that A was currently hanging on, which is the same object that P and Q were hanging on. Okay, so look, this might seem horrendously confusing, but the reason that I am sort of giving this as an additional video tutorial rather than sort of core materials on the course is because it's actually quite surprising how little you have to think about this when you're writing code. The only time this really comes into play is when you actually want a copy of an object. And you'd be surprised how infrequently you really want a copy. You often, as you're beginning and you're starting coding, you often think, or you feel as you're doing it, that you might be making copies, that, you know, you do B equals A, then that you've made a copy of A and you've called it B, and you've done Q equals P, you've made a copy of P and you've called it Q. Of course you haven't done those things at all, you've just been moving labels that were hanging on objects in memory. Sometimes, however, you do want to actually make a copy of an object, and Python has a function called copy. And it's in a module, so you have to import it from copy. There are actually different types of copy, so there's copy and deep copy. I'm going to just import copy. Deep copy and copy behave slightly differently depending on what kind of object you're looking at, but we're just looking at quite a simple object here, so I'm just going to import copy. And then I can do R equals copy of P. Okay, so then I'll look at R, and R equals 1, 2, 3, 4, 0, just like P and Q. But now if I do something to it, it's now actually we've got two objects in memory. We've got one object, 1, 2, 3, 4, 0, which has got P and Q, labels P and Q hanging on it, and we've now copied that object, we've created a copy of it, it's exactly the same, but this one's got R hanging on it. So when we do R.append 9, for example, let me take a look at R, it's got the number 9 stuck on the end, but if we look at P and Q, they're effectively unmodified. So the thing is, I mean, it's actually really rare that you actually want to do this. Although you might think that that's the more sensible behaviour, it's actually not. If you copy everything, it just you end up filling up your memory with a proliferation of objects, and usually you don't need to do that. But it's worth knowing about, okay, for the rare occasions that you do actually need to copy something, and it's worth knowing about the way Python treats these references and objects, so that you don't, bugs can arise if you're not entirely aware of the way it's dealing with it. And just to finish, one other thing is quite interesting, worth thinking about, is what happens if I do A equals 100. So I create an integer in memory, an object in memory called 100, and I hang a label on it called A. Okay. Then I do A equals 20, so I create an object in memory called 20, and I want to hang the label on it A, which means I need to go and get the label A, which I've already created off 100, and hang it on A. Okay, all very well. So the question is now, what happened to 100? Okay, the object that I've got in memory, because there's no way of getting it back. I can't access it now, because there's no labels hanging on it. It's essentially sort of a disconnected object sitting in the computer's memory with no labels hanging off it, and who knows what happens to it. Does it go to heaven? Does it go to hell? I don't know. But hopefully Python has some kind of memory cleanup operations running in the background that take care of these kind of disenfranchised objects hanging around in memory, so you don't fill your memory up with them. But the truth is, I actually don't know. So anyway, that's it. Objects and references. Of course, I suppose I could just Google it. Yeah, maybe I'll do that.